Okay, everyone, welcome to the next call on the cyber infrastructure group. And today we have Ed talking about MetrANOVA. So with the whole, take it away, Ed. So
Yeah, yeah, thanks, Ken. And yeah, this is some of this is content that you may have seen at prior meetings. We've also added the back half is a set of kind of more details about what we've been up to since the last time we presented on this. But as this is only our second time talking about it, I think I wanted to kind of just do a level set as well. Um, it is you know, I'd say if folks have questions or whatever along the way, just try to grab my attention. And this isn't a super formal deal, right? So, but anyway, yeah. So I want to kind of start off with a little bit of context setting, I guess you could say, right? So this is if I were to like draw a sort of a timeline of my career before getting into the RD networking space, it might look like this, right? And really, it starts with me in college in 1991, and that's where I became familiar with TCP/IP, and that was really a mind-blowing sort of experience for me from a technical standpoint, right? Just the combination of open standards, the loose coupling of the layers, the idea that we would provide ubiquitous access, and that there was in particular vendor neutrality at the time was really a high hurdle, but quite a bit of technical optimism, right? And that's, I think that spirit really, in my formative years was the thing that really got me motivated, and it still to this day motivates me, right? And it served me well. But elsewhere, of course, Microsoft was trying to be uber dominant. I had for a while worked in an organization called ESnet that got bought out by AOL, of all places, which was an interesting place to work. They did a great job with operations, but they eventually got they got sold to WorldCom, and so I think in a short span of time, it went from seeing the internet in its infancy explode in a magnificent way to then also seeing what can go wrong when you have bad leadership, right? So in my mind, some of the strongest lessons I learned in the commercial space at WorldCom were what not to do and how not to live my life. But I think the idea here is, I'm not getting any younger, and while I still do a lot of interesting, relevant stuff, I think that the same is true for the broader R&D, right? There's a lot of us that are of a similar age to me. We're not spring chickens, as it were. And I start to look at continuity planning in the space of measurement, and that's really where I started thinking about what is it that makes RNA special, and in particular for measurement, there's a lot of these barriers. What can we do about those, right? So if you were to ask me, what do I think the secret sauce is of RNA, I do think it's this idea of those I'll call them timeless design constructs that I feel like they'll always be sort of important, right? And I'll also add the idea of rough consensus and working code, but it's the ubiquitous access, again, the open standards and neutrality, et cetera. But it's also taking those technical constructs and combining them with community. We aren't driven entirely, we've got to obviously make the ends meet, but we're not driven entirely by profit. And I think it's those values that differentiate us. And the result of that is, while we may use the same technology that cloud providers or big internet providers provide, how we apply those to address our needs tends to be a little bit different, even in things as subtle as our traffic engineering methodologies. But that's really what I would say, if an elevator pitch level, what makes RNE I think important and valuable, right? And so what I want to talk about is this consortium we've created. And before I do that, I want to talk about, often I'll say we've created a consortium for advancing measurement and monitoring, and people are like, what do you mean by that? And so this is a quick slide, kind of covers what I mean by that, right? So I take a very loose stance in terms of what is under that tent, in terms of collecting data, cleaning the data up, adding the relevant metadata, and then storing and possibly aggregating it so you can use that data in portals, right? So the data in this question would be any kind of numeric data, it describes the state of the network, right? I think that's the key, and often describes the state of the network over time. So time series data becomes almost central when we talk about measurement and monitoring. Typical examples might include obviously S&P port counters, network flow, but also things like optical light levels, end-to-end loss and latency, like our beloved perf sonar, also per application metrics. So if you have a set of web services, you may want to know the latencies there or the rate of error on those. But it also can include routing table stats. So these are all things that we, at least my day job, we've looked at. And your typical systems you might think of when you think of measurement and monitoring would be, of course, perf sonar, but also things like Stardust and NetSage that came out of, and TSDS that came out of the R&E community, but also commercial offerings like Kintech, Arbor, and Deepfield, right? And then those that lie somewhere between, usually they're open source, but with commercial offerings like Nagios, Prometheus, and TICStack. So that's the, I guess, the mile high view of what I think of when I think about the measurement and monitoring space. And why do we care about that, right? So at least in my pre-R&E life, it was interesting, right? So in 1999, there was this thing called ATM, and ATM networks were basically were the underpinning for all the wide area networks, at least that we ran in WorldCom and UUNet actually in particular. And it was interesting because they had vendor proprietary management systems, and I was sort of working in a rogue unit there, trying to figure out how to support these. And I was using generalizable methodology. Basically, I was using SNMP, and at the time, the only thing we could really look at was just a few metrics and MIBs, and one of them was the CPU stats. Well, it turns out that was a rather useful thing. We were able to just identify hours before the main software was able to identify. We identified a problem where basically the ATM network was melting down because there was essentially they basically bridged two the equivalent of IGP areas together to create a topology that was so big that the ATM switch CPUs couldn't handle it, and they were basically melting. We figured it out, and it took the rest of the organization about 2 to 3 more hours to finally agree that, yeah, we were on to something, right? So that was my first sort of inkling that, hey, there's some interesting ways to do monitoring and measurement that if you do it right can be really advantageous. And here's a few other examples. I won't go into the HoneyNet one. I won't touch just for the time, but I'll talk a little bit about Hurricane Katrina, because on the right there you see like a typical weather map. That's an example from IU called Worldview, but the origin of Worldview came about when Katrina, the network maps at the time would show a network as a times basically as a colored graph, often logical layout. In what the Worldview developers figured out is, oh, if we use a geo-referenced view of the network and combine it with next-ride radar, we can really get improved situational awareness to tell what part of the infrastructure might be impacted. And so that was one of the first forays of mixing network data with GIS data to come up with a sort of a data fusion strictly related to network measurement and management. So, often people, when we started talking about MetrANOVA as a consortium, people ask, why do we need another consortium? Can't we use any of the existing ones? And, you could potentially use perf sonar, right? But really for me, when I think about why we created our own independent consortium, it came down to measurement and monitoring is a core competency for all of us in R&E networking. And it's not easy to do well. And it's something that has a ongoing investment in that things bit rot. And so it needs constant upkeep. And so anything we can do to lower the bar for sustainability and quality is, I think, a worthy endeavor, right? And we know that our community can collaborate and produce reliable solutions because we have a pretty good track record in terms of perf sonar, all the in common work, et cetera, right? And then the third motivation, as I alluded to earlier, we're all aging, or at least I am. I think I look at my peers and we're not retiring eminently, but some of the people that I look up to have. And we don't want to lose the sauce, right? And at the same time, we want to make sure that those that are earlier in their careers might choose to work and have opportunities to grow in R&E, right? We don't want to kind of ossify and then age out. We want to get the new blood in there. So that's an important thing. And then the other reason is that in the broader industry, we're seeing a lot of trends that point towards significant technical opportunities, right? So whether it's Internet of Things or some of the derivative cloud technologies, there's a wide variety of building blocks that we can apply to really scale to meet the measurement and monitoring needs that we've always kind of wanted, right? So what I'll do is I'll talk about a little bit about the structure of MetrANOVA and what its visions and goals are, and kind of go from there. So first off, who is MetrANOVA, right? They're sort of like Persona. There are these core members. So the founding members at this point are ESnet, Géant, Global Knock at Indiana University, Internet 2, and TAC. And it started basically, if you think about all the past work in let's say NetSage and Stardust and all that, there's a cast of characters there that knew each other well, and that's where the basis for that started. While we start here as founding members, we expect to grow beyond that, assuming that we can really strike the interest of the broader community. And so unlike Persona, there's two modes of participating in MetrANOVA. One is the member route. That's very Persona-like. The idea is you commit a 1 FTE or more to the project, with half of that coming from at least one individual. And members, they'll contribute in various ways, whether it be management, technical contributions, documentation, you name it, right? And then as an organization, those members participate in the governance process. There's a second mode we call affiliates. And the idea of affiliates is if you can't contribute at a level of 1 FTE, you can become an affiliate and contribute on a best effort basis, right? So the idea there is they have more flexibility in terms of level of effort. You can figure out if that's something you want to invest in, but you still get to influence and contribute to the broader effort. And it's a lighter weight way for us to provide a structure that supports individual contributors that might want to get involved, but maybe not at the same level as a full member. So that's the first sort of, I guess, if you look at the way it breaks down. In terms of the consortium lead, so we have one person. It's currently me that basically is the wrangler, right? So my role is to provide guidance at a leadership level, but also technical leadership when there's gaps. I also liaise with the executive committee to make sure that what we're working on is relevant to the members. And in general, my job is to crack the whip now and then if need be to make sure things get done, which, people are pretty good doing their own thing. So my job's pretty easy there. So executive committee, these are the folks on it. We have one, so from every member, we've got one individual. I don't need to go into details, but really just like a board of directors, the idea of the executive committee is these are the folks that make sure in the long term they're doing relevant things that are of value to those member organizations. And then individual contributors, right? So that's all the folks that are actually doing the lifting. So we do mostly right now have folks that are, I'd say, developer centric, but we do want to keep the door open for a mix of skills, right? So whether they be people that are really adept at applying techniques in operations or developing software or doing training, you name it, we need all kinds of people to help over time, right? And we already talked about the member thing. So in terms of goals for the consortium, it really comes down to it's basically tools, tactics, and techniques is how I might describe it in a mile high. So whether those be technical solutions or methodologies, right? I think that's the idea. But we want to develop and share open architectures, technical components, design patterns, best practices, and also importantly, policy recommendations. So, we realize that just creating a technical solution that is devoid of good policy guidance isn't going to get everybody what they need. And so we want to make sure we address the socio-political boundaries and develop technical solutions that can accommodate the realities of our community, right? And in general, we want to facilitate composite views of the whole R&E cyber infrastructure. So, while we may not be the ones that actually are creating those composite views, we want to make sure that the whole community can get together and in reliable ways and controlled ways share their data so that they have a more comprehensive end-to-end understanding of what's going on, right? So that's kind of the goals of the consortium itself. Vision, so if you think about, okay, so what do we think this is going to look like? What do we wish to be true in the future? I think the idea is really we want to have a collaboratively developed ecosystem that meets all, any measurement and monitoring needs in the community. We hope to be a part of making that a reality. And we presume at this stage that open source with loose coupling and without dependence on cloud services is going to be essential. And so that last part in particular, that's not to say that somebody couldn't take the building blocks that we're going to work on in MetrANOVA and deploy them in the cloud. But it is to say we don't want to have dependencies and that would result in people having to operate in a cloud and not in a local deployment. So that's just something that I think is a little bit of a corner case, but I just want to make sure we touch on that. And the other part is we do hope that this becomes a foundation for production services. We may not ourselves directly be providing these production services, but we do hope that there's a foundation there and that that provides the basis for future innovation, especially with a good architecture. So, we hope that the base layer being a solid production ready kind of service means you can innovate above that, right? That's the goal there. So, and ultimately our hope is that wherever possible in the R&E networking community, that data-driven design and operations becomes common, right? I think that's ultimately for us, it's not just enough to say, oh, look, we built tools to collect data. We want to be able to provide a means to collect and analyze data that provides those insights that allows us as a community to make better decisions. I think that's ultimately the metric for success here in a pie in the sky sort of vision way. So what's next, right? So that kind of covers what the consortium is. I think the first thing in terms of what's next is if I will put this pitch out for those of you that have not seen this. We have an active community survey. So we've conducted a survey for ourselves internally for bootstrapping purposes for the members. But what we really want to do also is get your input into this because you have a key voice in guiding the consortium long term. And so for those of you that have an interest in the space, if you could take a moment and take a shot of that QR code and fill out that form, it would really help us as we look at our long-term roadmaps and where we focus and what problems you have and how we might be able to solve those. So that's the immediate thing. What's next, right? So and that pretty much covers in very terse form some of the formation efforts and initial just here's what MetrANOVA is. So the next natural question is, all right, great. You've given this talk a few months ago. What have you been up to since then? And so this is where we get into some of the new fun stuff, right? So yeah, so obviously we launched the community survey. So that was what that last slide was. And we have conducted an internal member survey. And based on that internal survey, what we have decided is that at least in the initial year, and especially waiting on the community input, there are two areas that we're going to focus on, and we've organized ourselves in the work streams around this. The first is what we call a vetted technical stack. So there's a lot of commonality in some of the tool chains in use. If you think about NetSage, Stardust, Personar, even in what is known as TSDS at IU, there's a lot of shared ideas and componentry there. One of the things we're going to start with is by getting an understanding of what's being used in production today, and also providing some assessments as to how suitable they are for certain tasks, or what's their performance envelope, that kind of thing, right? So that's in the near term what we're going to be doing on the technical front. On the policy front, there was strong interest in us sort of gathering all of our known data sharing and data access policies, and just kind of crosswalking those to understand what is common or uncommon in those, what the gaps are, and seeing if we could work to provide guidance for those that may have data but are not sure if they could share it, or for those that are new to this space, what concerns they should be thinking about to manage risk, and to basically just set themselves up for success down the road when they do decide to share data. So but both of those are things that we've just, as we've been staffing up as a consortium, we're just starting to scratch the surface on those. So in the rest of the talk, I'll touch on the technical work. The policy guidance is just getting off the ground now. There's not a lot to share. And on the technical work that I'm going to talk about, much of this is still moving. Some of it's preliminary results, so it's a little bit bleeding edge, and bear with us. My hope is by the time we get to like a TechX or something like that later in the year, we'll have some of this to be a little more authoritative. But yeah, so I mean, basically it comes down to several things. First one is visualizations in Grafana, and this is a lot of the work we've got going on, or had been going on at ESnet in Stardust, related to creating custom visuals to suit the network analytic use cases. And we've been doing that in close partnership or collaboration with Grafana. So those two URLs, one of those is from the NetSage plugin we created even further back. The second URL shows some of the plugins we've created as part of Stardust. But the end result is Grafana shares those openly with the world. We provide support on those, and they do things like create a network map, or create a matrix diagram for Personar, or a Sankey diagram, or a core diagram to kind of help visualize network interactions, right? And that's been a really, I'd say, a really positive collaboration for us between ESnet and Grafana. And we're in the process right now of widening that to basically not be just solely an ESnet effort, but just bring in all of MetrANOVA, all the members, and meet their needs, but also if they want to contribute code or documentation, make that kind of pivot from it being an ESnet centric thing to being a MetrANOVA thing. So that's a in the works kind of a deal. Our first area in that regard is the map widget you see there is something that's under active development. Its primary goal right now is to get it added to the Grafana official registry, that where you have to go through a certain QA process, and they provide code review and all that. So we're in the final stages of getting through that, in which case it'll be easily accessible to all. But the other thing we're doing is we've been working with other members like TAC, and in particular to support their Epic work. We're expanding the map to some of their use cases that aren't currently supported. So that's just an example where the consortium is starting to work together to provide capabilities that we hadn't thought of, but others have need for. So that's already, I'd say, being mutually beneficial within the consortium itself. So the next thing we've been looking at relates to storage density, and this is another one that's kind of driven by, in particular, the Stardust system within ESnet. So this is a slide I stole from Andy Lake, but it basically just gives you a mile-high view of what Stardust is. So Stardust is our multi-data source measurement environment in ESnet. It happens to run in Google Cloud, but is not dependent on it. At its heart, it is using Elasticsearch for data store, at least for most of our data. We also have some ClickHouse data that we play around with as well. But the idea is all the data that we collect about the network that is measurement related is going to end up in this system. So traffic, network flows, interface usage, all that, right? Like I mentioned earlier, all that data is in Stardust, and as much as possible, the metadata we use is consistent across those data sources so that we can do cross data source analysis, right? The system also allows us to do a variety of aggregations, and so we can summarize in time. So you can imagine 5-minute, hourly, daily summaries, but we can also summarize in dimensions. So you can go from specific IP addresses to maybe an origin AS, those sorts of things, right? And that's all great, right? It's been an awesome system, and that system also, just for historic sort of references, that system, some of the early efforts at doing things in scale really started with NetSage, and we've expanded since then. So Stardust has been around for about 3 years, and it has actually succeeded. It has exceeded our expectations significantly, right? So we are currently running over 3 times the number of flows than we anticipated at launch. And we've expanded the number of data sources well beyond flow, which was our focus, to SNMP optical, open telemetry, streaming, and many other things, right? So it's really a success story, but it also means we outgrew our expectations. And so we're taking a step back, not really taking a step back. While we're doing all that, we are taking some time to review all of our engineering assumptions we made, because it's been a while, and so we're looking at the tunings, the scale models, et cetera, what features we're using. Our plan is to do a write-up on that, sort of retrospective, just because it's been a long time. We could talk about what's worked, what hasn't worked there. So shared lessons learned is the idea there. But the other thing we're doing is we're looking at the ecosystem, the Elasticsearch ecosystem, and saying, are there features that have come out in the last 3 years since we deployed Stardust that we haven't really looked at? Because really, since we deployed that, we've been adding data, but we haven't been refactoring the fundamental storage regime or our architecture. Our architecture has been amazingly stable. But one of the questions is have there been innovations on the Elastic side that have improved things? And the answer is we think there might be one. So this is something that Dan Doyle has been looking at for us. They have this thing called the Elasticsearch Time Series Data Streams, which is ironic that it's TSDS is the acronym, but if you Google that, you'll probably run into this article that claims up to 70% savings in storage. And we have seen, I don't know that we've seen 70% in our initial testing. We've seen, I'll just say right now, non-trivial savings that might be closer to 50, but we're also looking at it for both flow and port metrics. So we are concerned yet that, what is the total impact of this? So we haven't deployed in production. We're just now doing some burn-in testing at partial scale. But the plan here is we're going to run it through its paces, and we hope to have the assessment completed in the next month or so. And if it's looking promising, we'll for sure be probably early. I don't know if we're early adopters. It's been around for a year. But we'll probably be deploying it on Stardust and sharing our findings as well with the broader community. We don't think this will have a qualitative change in our capabilities. We just think it's going to help, move the needle in terms of our scaling capabilities, though. Okay, so here's the next item I want to talk about, which is we have been looking at switching from SNMP based polling of interface metrics to streaming telemetry. And so this kind of coincided with somebody was asking for a new type of map, and we noticed some peculiarities in the SNMP data, and we started digging. And so what follows here is what happens when a director asks a question you've heard 1,000 times, and you're like, I wish I could answer it better than that, so they don't keep asking this every year. And so that's what this really is. This is an effort to understand really what's going on with SNMP. And so the TLDR is, as we dug in, is almost all pollers, at least if you use Telegraph, and the underlying library, which is very popular, they make a bunch of design choices that definitely impact the accuracy of the time dimension of what you might call a time series data collection. So how we noticed this is we had, I'm going to say, instantaneous rate calculations. So if you imagine you're pulling in a 30-second interval, at t-0, if you calculate a rate between t-0 and t-1, we were seeing impossibly large rates on interfaces that would exceed the line rate. So if we have a 400 gig interface, we might see an 800 gig value or beyond. And we're like, how is that even possible? And, so we started digging into that, and, what I'll describe here is our efforts to characterize what that error looks like. And as we were doing this, we realized this is a case. We had been looking at streaming telemetry primarily as a way of getting access to more data from the routers. We didn't dawn on us that it would be a potentially qualitative improvement in the data we do collect already. But what we think is going on is that we think that streaming telemetry in certain use cases will definitely provide a qualitative improvement, and that's something that we can't show yet. But what I'm about to talk about is our efforts to sort of do that baselining before we get into that. So here's a graph of just you see here the green represents the essentially it's if you think about it, it's a distribution over time. That's the interquartile range, and here's your median or your 50th percentile, so you're nearly your mean. And this is all interfaces, including edge interfaces and unused ones. But you do see a case here. That white line represents a 400 gig threshold, and you can see cases where the max and the near max 99.99 percentiles are exceeding what would be considered line rate. And this is just over, this is just in over a short period of time. If you look at, say, instantaneous rate measurements over an entire year, obviously there's many cases where that's occurring, and then people say, well, why is that happening, right? And so what got us into this was this map on the right. So this is the idea was we were trying to create like a high watermark map. So think about like go to your favorite low-lying bridge near a river and you see how high the floodwaters come up. So we were trying to show what is the peak usage. This is just sort of like a fun little graphic. What's the peak usage across the entire backbone last year, at a glance, right? Well, when we would do that using all the data we collected, we would see impossibly large values. And so then, of course, the users that ask for it would ask, why is this happening? Is that not, do you have a bug in your system? And, so then we'd go, we debug and confirm that the values are not let's say a computational error, but rather they're sort of basically a sampling artifact. But we never had a good way of quantifying that artifact, right? And so it basically meant it was hard to, in a confident way, explain that that they shouldn't use the data in a certain way, right? And we had no way of articulating the limits of suitability, is I guess what I would say, or appropriateness. And so normally what we do is we just avoid we'd avoid looking at those instantaneous rates, and maybe only look at like 5-minute rates that were calculated from the deltas of the counters, instead of looking at those rates calculated instantaneously. So what I'm about to talk about here is looking at just data from ESnet alone, and our polling infrastructure today is telegraph based. We poll on a 30-second interval. We do 10-second timeouts, SNMP-v2. The routers are able to update the MIB. Our understanding is every second. So we don't think that that's a factor in this. And we do know that we have other pollers hitting the routers, inducing load that we're not able to observe, right? So But, what we had done first was we started seeing some anomalies in the data. So we first looked at the source code. That's the beauty of open source, right? And it turns out, basically it comes down to the Go SNMP library it's bulk walk. It's using a synchronous pattern there, right? And the Go routine itself, you basically per collection per router, it's going to add the timestamps to the data it collects when the whole poll cycle completes. So that was what the code showed us, which basically the implication of that is that those timestamps, the accuracy of them is going to be quite variable, and it's going to be driven or dictated by the total time to complete the poll cycle, right? And so round trip time, or let's say variability in round trip time, is going to affect that quality. The number of MIB entries in the MIB table in each router is going to affect that. The load on the router at any given time, and in theory, in the poller is going to affect that, right? So just looking at the code alone, our hearts sunk a little bit. Like, oh boy, that's going to be this is not great, right? And so what we did to try to measure this empirically was we turned to PCAP, and on our poller, basically we ran T-Shark, the green command there basically allows us to grab all of the SNMP get requests going to the routers from a poller, and that minus Y option, the filter is looking for a specific OID. And so it's basically, we know if it's looking for the interface counters, it's going to be from one specific poller on our poll server. And so this just gives us essentially a time synchronized way of looking at a PCAP. And so we basically looked at all 76 routers over 2 days. So this was just an initial sort of analysis. But in that time, there's about 19 million PDUs that we collected. And then we basically took that CSV, loaded it into Jupyter notebooks, and started to beat on the data and take a look at what we're seeing. And so first thing we see here is we created like a little scatter plot of a time series of all the routers, and you can see there's let me take a step back. Each one of those dots represents the number of PDUs sent per unit time by one given router. So in theory, each color is a unique router, although with 76 routers, you're going to repeat colors. So each dot represents a unique router is generally the way you could think about that, right? And the issue here is you look and you see some stragglers in the time domain where occasionally you definitely get these outliers where the routers, as you see to the far right there, you get these significant delays. And even more interestingly, those delays are not consistent. So you can see the cluster there on the right of 3 green dots. Well, those aren't in the preceding polls showing as being late. And so that's going to represent variability in the poll duration, based on the way that the time stamping works in Telegraph. So you can see there as an example where those gray dots, in period 0 are fairly delayed, they're happening later in the poll cycle, and then the subsequent poll cycle, they happen, nice and quickly. So again, that's just an example of delay. So we took that data and we just basically summarized it into 500 millisecond time buckets. And then what you see here on the right is basically each router is given a unique ID. And it's just a series of box plots, right? So for a box plot, what you're really seeing here is the blue line represents your range between your 99th and first percentile. The green is let's just say your mean, and then the blue box represents your interquartile range, and dots represent outliers. So you can see here, for the most part, the 99th to 9th percentile, yep, they're fairly consistent. You definitely see some of these that have some significant variation in delay. And then, of course, you get some outliers where you're seeing on the order of 10 seconds of jitter, basically, I'll call it, happening. And so, yeah, okay, maybe we've got some problems there, right? So those would be your problem children potentially, but really the issue is it's kind of all over the map. So what do we think is going on there, right? So we dig in, and really what's going on is this is sort of representation where you've got these 30-second windows, and the poll cycle always starts at the beginning of the window. We can observe that it's working well, but it takes variable delay, and because the timestamps are taken at the completion of the poll cycle, it means that basically the variability becomes the source of error. So that's what the orange box represents, and the result is it's going to, that jitter in the poll cycle ET means when you calculate a rate, sometimes you might be taking a 30-second measurement and dividing it by 33, and sometimes you might be taking a 30-second measurement and dividing it by 27. And whether you are underrepresenting it or overrepresenting it is hard to determine, and is based on when the router might have updated its internal counter and where in the get next sequence of 15 polls to a given router you gather that data. But what we know is there's a source of error, and it's somewhere within that window of approximately the size of that poll cycle duration. So yeah, basically it becomes jitter, and it looks something like this, right? So we take that same data and we plot it. The mean jitter is just under 1/10 of a second, but the standard deviation, so that's about 4.8 seconds. It's a little more than we were expecting. So okay, that's not maybe. So what does that mean? Right? Is that bad, good, or otherwise? So the next thing we did was we create a model. So this is just gives you a sense of we basically created a software simulation, and the green up here in the upper right quadrant shows us trying to do some modeling of a 30-second poll interval of 4.5 seconds, 60-second interval, 300-second interval. So that'd be 5 minutes, 1 minute, 30 seconds. And you can see the distribution of rates over time, and then also what that's going to be doing to your ET distribution. But more interestingly, we took that data, and then we basically looked at the root mean squared error expressed as a percentage, and that's what these lower graphs show. So you can see if you had 4.5 seconds of jitter, you would not want to be looking at, let's say, 5 seconds, obviously, or 10 seconds poll intervals, because so much of that's going to be garbage data, and it's going to be it's going to be nearly completely garbage, where you really want to be probably closer to the 1 minute or 5 minute interval, right? So that was sort of interesting to us. Now, as I say all of this is our initial swing at this. And so we need to do another go and have another pair of eyes on this. This is just something I've been doing last week. But it seems to indicate that, at least for for super frequent poll intervals, we probably don't want to do that, right? So I think that's what it's telling us, right? We'll we'll figure that out. We don't typically today. We had an intuition that this would be a problem. So almost everywhere in Stardust, we do not use the instantaneous rates. We typically report things on an hourly or 5-minute basis, and we would calculate the rate based on the cumulative number on the bit count, not the rate calculation. So, but I think in the end, we think that when we go to streaming telemetry, that will address this, because in streaming telemetry, the PDUs actually contain their own timestamp, and so that may mitigate this entirely for those narrow use cases where you do want instantaneous rates. But the punchline is, we think we can predict what the error is going to be. We're pretty confident at this stage that is just an inherent issue, we're going to call it a sampling issue, or an issue with the collection methodology in SNMP today with the implementation. So our next steps, of course, are going to be to validate this, and then also to try to work on mitigations that we can do through the configuration of Telegraph. While we could modify the source to Telegraph, I know that this issue has been reported to the developers, and they have declined to change the behavior, although I believe that's because the behavior really originates in the underlying library they're using. So once we get this collected, we may reach out to them and provide some guidance on what we think might help, but we don't have that guidance fully baked yet. So just that's to be determined. And then, of course, the last thing we're going to be doing is we are in the process of migrating from SNP to streaming. Our initial motivation was not qualitative in nature. It was to get access to new types of data. But now, as a result of this, we'll also do an analysis of the impact that change will make. So that's the next thing for us. And yeah, so that's pretty much it for me. We've got 12 minutes. If you are curious or have further questions, obviously here's my contact information. The MetrANOVA website can be seen at the lower URL on the right. We do have everything. Well, I should say we're starting to put everything in GitHub, so at least we have our main governance documents there, our work tracker. As time goes on, we have things to share, like let's say lessons learned documents. Expect those to be available on the web and in GitHub. So for instance, the numerical model, I'll be sharing that soon in GitHub in case it's useful to other people. So I will stop there and entertain questions now.
Okay, thanks, Ed. That's great. I don't see any questions in the chat. So anyone else have any other questions or anything?
And blinded them with science.
Yeah, I guess.
Oh, I have a question. This is Julio Ibarra.
Hey, Julio.
Hey, Ed, thank you for your presentation. Very impressive results with your Stardust tool. But I wanted to ask you, how did you then present your findings? How do your findings then um, with Stardust and ESnet relate to what you're doing with MetrANOVA?
Yeah, so in one level right now we know, so this is the part where we're kind of bootstrapping. So Stardust, one of its components is Elasticsearch, and we know that at least two of the members, well, actually, I guess three of the members use Elastic somewhere in their infrastructure. So we know IU uses it, although I think on the OmniSoc side more. I'm not totally familiar with that, but I know IU uses it to some extent. I know TAC uses it. I know we use it. And so this is a target of opportunity is why we're sharing it here, which is our plan is to use MetrANOVA to share lessons learned about technical components. And we're not necessarily saying, okay, we're going to create a stack based on Elasticsearch. We may or may not do that. But right now, what we're saying is, hey, as a technical report kind of level outcome, we're assessing the capabilities of that feature for those that are doing Elasticsearch is I guess the relevance there.
Okay. And as a follow-up, your other members, such as Internet2 and Jayant, are they doing a similar study?
So we're all kind of working. So at this stage, this is sort of a target of we have this one thing. What we were hoping to do with the other members is we're just in the stage of kind of moving from let's share what we're doing ourselves to starting to figure out where do we think we can have synergies as to shared components. Whether they do similar assessments of their own componentry, one of the things we want to do is kind of like a SWOT analysis on those components, right? So whether they have already done it or whether they need to do it, that's something we're going to figure out in hopefully the next month or so.
Mm-hmm. Okay. Thanks.
Yeah.
All right. Any other questions? All right. I guess thanks, Ed, for everything. It's great.
Yeah.
I'll get this recording stopped and I'll get this uploaded to Jason. We'll get it put out to YouTube and then look for more emails for upcoming talks. And thank you.
Awesome.
All right. Have a nice weekend, everyone. Bye.